All right, so our last graph here is another classic polar curve, actually called a Lemniscate. So this is, I'm going to call it like a new parent polar function called a Lemniscate. And that is actually the word for the infinity symbol, I believe. I think I looked that up before, so you guys can double check me, and maybe we'll see why they use that word. But these graphs will be of the form r squared, which is a new form we've seen before, equals a squared cosine 2 theta, or same thing with sine. And I would maybe try to graph this on your calculator Desmos. Remember, you can only graph r equals. So we could solve these for r, right? We'll have r equals, I'll do sine. I'll actually just solve this equation for r, right? It would be plus or minus square root of 16 sine 2 theta. So you'd have to graph it as two separate equations, a plus root 16 sine 2 theta and a minus root 16 sine theta. So to graph these, again, a couple things that are helpful. This graph is actually going to have, and our first graph that has symmetry, I'm going to say WRT with respect to the pole. And that would be, and this was actually the graph example we used, if we have a point r theta, we also have the point, I'm going to call it negative r theta, right? Like pretty much directly across the coordinate plane. And we could check that if I put a negative r into this graph, these equations would be equivalent. So that's how we would check for symmetry with respect to the pole. And I just think the easiest way to graph this guy is to throw in some points. But another good thing to note is it actually really closely resembles our roses, right? Except now we're never going to be able to get a negative value for r because we're always squaring it on that side is kind of the way to think about it. So I'm going to use this equation to help us graph. I'll just do a point or two here, right? Like if you put a 0 in for sine, you're going to get a 0. Pi over 4 is a really nice one. You guys could still graph this in the xy plane, right? At least this guy, and think about the root values. So pi over 4 would turn this into sine of pi over 2, which is 1. So we'd have plus or minus root 16, which is really positive or negative 4. And that's going to be the highest value we ever get out of that, right? When sine is 1 is our highest. So pi over 4, 1, 2, 3, 4. But also negative 4. Not too many other great values for this one. If we put in pi over 2, would also be 0, because that would turn into sine of pi. Anything that makes sign negative is not going to work. So like if I tried 3 pi over 4, that would turn into 3 pi over 2. That would give us a negative under the radical, so that guy wouldn't work. So I'm going to try out, let's do a little smaller one. Let's do pi over 6. And I know I'll need to grab my calculator for this one. It'll be 16 sine. If we did pi over 6, it would turn into pi over 3. I actually threw it into the calculator, and this works out to be just about 3.72. So at pi over 6, I'm still pretty close to our original value. And remember, symmetry with respect to the pole, which means I'm going across, and it's there. So this guy, and I said Lemniscate means infinity symbol, actually looks like a figure 8, right? The infinity symbol. So that would be our Lemniscate. All right, to wrap up our notes today, you guys have a little kind of challenge at the bottom here, or just think about, I mean, do a little research online, but I want you to think about how could you graph a spiral in the polar coordinate system. So maybe do a little playing around. This is in our book as one of our classic polar curves. And by a spiral, I mean we start at 0, right? And then our radius just keeps increasing at this linear rate is my hint for you. So maybe do a little Googling or research and see how that would come up.